Right, so this is just an introduction to some of the basic things about acids and bases that I want you to be aware of as we move on to acid reactions. So follow along with your notes. First of all, just looking at acids, they have a pH less than 7, and if we use the universal indicator, they will show up as a red color to almost sort of this yellowy color for some of the weaker acids. The acids are made up of obviously two or more elements, and one of those elements is common throughout. And you can see here, if you look over to the side, all of these acids have one thing in common, and that's obviously hydrogen. Acids that are made up of just two elements, so hydrogen and something else, we have a special way of naming them. For example, hydrochloric acid, which is made up of hydrogen and chlorine, we start off the name with hydro, then we say the other element's name, so chlorine, but instead of chlorine, we change the ending to ic, as you can see over here, ic, and then we just say acid, so hydrochloric acid. There's another example here. Here we've got hydrogen and sulfur, so again, just two elements, so we use this naming rule up here, and we started off with hydro, sulfuric with the ic, and then acid. Some acids are made up of more than two elements, and when they're made up of more than two elements, remember that hydrogen is still one of the elements that's present. Like if you can see over here, there's sulfur, oxygen, and hydrogen. So hydrogen's still there, but it's made up of more than two elements, and we have a different a different way of naming these acids. So before we started with hydro, when we have more than one element, we do not start with hydro. So I'll put a cross through that, because we're not starting with hydro. For these ones, we have to look at what the polyatomic ion is that makes up the acid. So in this case over here, you can see SO4, and we looked that up on our polyatomic ion chart, and we can see that's sulfate. Now the ic part replaces the 8, so I'll cross the 8 out, and we cheat a little bit with this one to make it sound nice. We add uric, but it's that ic part that I want you to be familiar with. So you get rid of the 8 and add the ic, sulfuric acid. So if we do this one, nitric acid, you know that the ic has replaced 8. So it was nitrate. So we know that nitrate is going to be part of this one. So make sure that you have that polyatomic ions chart nearby, because you know it's going to be NO3. That's the last part of this acid formula. And you know it has to include hydrogen, and the charges even out. One hydrogen, one nitrate, and this one we call nitric acid. Bases, on the other hand, are usually made up of a metal oxide or a metal hydroxide. For example, so strong bases will be blue with the universal indicator, and all the way over to sort of a green for weak bases, pH less than 7. And yeah, like I said, they're made up with a metal oxide or a metal hydroxide usually. So for example, over here, our metal is sodium, and then you see hydroxide here, OH. So you want to be able to identify that. You know, when you see this metal and then hydroxide or this metal oxide, then you know that we're dealing with a base here. So in this case, yeah, sodium hydroxide. This one here, ammonium hydroxide. So again, the OH at the end. Magnesium oxide. See if you can write this one in yourself. Obviously the metal part is magnesium, and oxide, the oxygen element there. The one below this, we can see that our metal is going to be copper, and again oxide at the end there, so copper oxide would be this one here. So these ones are bases, and I'm also going to talk a little bit about alkalis, and these are basically just bases that can dissolve in water, so they're soluble, and not all bases can dissolve in water. For example, copper oxide does not dissolve in water. It's not an alkali. However, sodium hydroxide is. So as soon as you see that we've got a metal and an oxide, you know straight away that we're dealing with a base. Make sure you've copied down anything that I've written. If any of it didn't make sense, go back and go through the video again. Always feel free to pause the videos and obviously move forward in the videos if you think that you're a little bit more advanced, and that's the purpose and the beauty of having it as a video. What I want you to do now is flip your sheet over, and we're going to write a few more notes just on carbonates, because when we do these acid reactions, we're going to look at what happens when we mix acids with metals, and how acids react with bases, and how acids react with carbonates. Now, carbonates are just anything with this CO3 here. For example, calcium carbonate would be calcium and carbonate. Now remember that our carbonate has a 2 negative charge, okay? So we've got to make sure that when we're bringing these together, when we're making these compounds, that the charges balance out. And calcium has a 2 positive charge, so you know that this one will come together just as Ca CO3, because obviously these two charges balance each other out quite nicely. Potassium carbonate, potassium is K, carbonate CO3. Remember, the charge of carbonate is 2 negative. The charge of potassium is just 1 positive. So we're obviously going to need 2 potassiums for the 1 carbonate. Remember, guys, that when I'm writing these compounds out, I'm not writing the charges above these elements. Okay, I'm just doing that when I see the words like this. I write out the ions, and that helps me work out how many of each ion I need. And remember, that's step 1 of balancing equations. When I give you these worded equations to balance, the first thing you're doing is you're writing the ions above each word so that you know how they come together. So you know the potassium carbonate has 2 potassiums for the 1 carbonate. The last one, sodium carbonate. So again, sodium carbonate, and I put my charges in, and again I'll need 2 sodiums, 2 sodium atoms to even out the charge of that carbonate. Right, so that's about it. Just make sure you remember carbonate, and remember its charge, because you're going to have to put that together with other cations. So you've got to make sure you can even out those charges and write the formula from the worded ones like we did here. Okay, great. Like I said, go back over the video and rewatch anything that did make sense if you want to slow it down or anything like that. Otherwise, you're right to move on.